Alright, so here's the good stuff. Advanced problems with the law of sines and cosines. I feel like this is what math is about. Like hard problems, advanced problems are what should really just be making us happy. I love dealing with problems that are a challenge, and I hope that you guys do too. A lot of times when you get into advanced problems, one of the strategies is, there will be two variables. You'll have an x and a y. And if you have two variables, very, 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 very commonly, the secret is get two equations and set up a system of equations and solve them. It's not going to be as nice and as pretty as the ones you had in intermediate algebra, but the reality is we can solve these problems. So I've got 3 of them here for you that are a little bit challenging. You may very well find that in the course of this video you're going to have to try one problem and then take a little break and then try another problem and take a break. But work through them and give these problems your all, and don't try to not resort to just watching me do the problems. Try and give them a little bit of a shot and see what you can come up with. So here's the first one, showcasing my artistic ability. A tree is supported by 2 cables running from the top of the tree to the ground. In case you can't tell, this is the tree, as shown in the figure below. The angle of elevation of the 2 cables are 39 and 50 degrees respectively. So it's sort of like, this is ground level down here. You've got a cable going up to the top of the tree that has a 39-degree angle of elevation, and this is a 50-degree angle of elevation. And it says the distance between the points where the cable is attached to the ground is 80 meters. So you've got this as 80 meters here, and the question says find the height of the tree. So how in the world are we going to do this? Well, on the one hand, you might start writing things down. You might, see if you're able to play with anything here. Some hints that I'm going to give you are these. First of all, you have 90-degree angles here, which means these triangles are nice 90-degree, like right triangles. I know they don't look like it, but it's because I was trying to draw this picture with perspective, right? So it's sort of like, okay, those are nice, nice things to work with. The other thing you have, and this is important, this is a triangle that sort of pulls these two together. So it's sort of like you've got one nice triangle that you can work with, another one nice one that you can work with, and this triangle, which is interesting, I know 2 things about this triangle, this sort of ties both of these sides together. So my thought in this problem is going to be, they want me to find the height of the tree, so we might as well call that x. So now this problem is effectively find x, right? My thought is, if I can find a length of this side and a length of this side, I'll then effectively have a triangle down here that's set up to use the law of cosines. And so that's sort of that's the strategy we're going to use for this problem. I'd like you guys to try this at this point. Fill in these 2 red circles. Figure out an expression for these 2 things down here that we could say, and then let's see if we can come up with that. So first, fill in those 2 red ovals. Well, focusing on the left triangle, what we can say is that the tangent of 39 degrees would be x over this side here. We'll temporarily call it question mark. So in other words, that question mark side is x over the tangent of 39 degrees. So this is x over tangent 39. Right? And we should have a really similar thing happening on the other side. We should have that the tangent of 50 degrees is equal to the height of the tree, x, over, opposite over adjacent over this side here. So same deal, this is going to end up being x over the tangent of 50 degrees. Okay. So now, and I don't know if you guys recognize this, but now, this is exciting. This bottom triangle down here, I now sort of have 3 sides and an included angle. So 2 sides and an included angle and the opposite side. This is set up really nicely to work with the law of cosines. Right, the law of cosines setup here is going to end up being 80 squared equals x over tangent 39 squared plus x over tangent 50 squared minus 2 times both of these guys, x over tangent 39 times x over tangent 50 times the cosine of 119 degrees. And this is a horrible looking equation, but the reality is this is one equation which has one unknown, we should be able to solve this thing, right? And I guess a question that I sort of want to ask you guys, and this is definitely a calculator question, how do you simplify these things? Like, how do I work with this here? And that's a tangent, not just tan. And so the thought is, couldn't this thing effectively be written as 1 over the tangent of 39 times x squared? So effectively what you need to do is take your calculator, do 1 over the tangent of 39, make sure you're in degree mode, and square that thing. That's going to give you a coefficient for x. You should be able to do that here, and do a similar thing here. What I sort of want you guys to do is, pause the video, get out your calculators, simplify that equation, and see if you can work through what that's going to lead to. And then we can sort of check answers with one another. So the left side is 80 squared. I mean, maybe I should just do that one. This is going to be 6,400 is equal to. So when I worked this out, I ended up with 1.234x squared plus, and then the next one was 0.839x squared minus, and then let's see here, 2. So this one ended up being 2.072, and then I times x squared, and I actually didn't do the cosine of 119 degrees. We'll have to come back to that. In fact, I'll do that now. Okay, so let's see here. I ended up with 6,400 equals. Now here I'm gonna square this thing, right? So when I square that on the calculator, I end up with 1.525x squared plus the next one squared was 0.704x squared. And then this next one actually ended up being plus 1.005 x squared. And so what you have here is a string of things that are all x squared, right? I should be able to move these things together. And I ended up here with 3.234 x squared. So I can divide 6,400 by that 3.23 business. I got 1,979.108 equals x squared. And so when I square root and solve for x, I end up with 44.487 meters. And that's my answer. And I recognize that this was not at all an easy problem. But I also believe that if you've gotten to this point, like working through these problems, at least understanding this process and potentially being able to duplicate it should be something that you can do. For some of you, this may be a stretch, but after we do some practice with this, I expect that this is something that we can do. I have 2 more problems. They both have strange twists and turns in them, so if you need to take a little break and stretch, go for it. But we've got two more deep problems we need to dive into. Here's this next problem. Find the values of a and b given in the diagram below. So I mentioned earlier in the video that a lot of times when you have 2 variables, sometimes the secret is trying to set up some kind of a system of equations that you can work with. And so I might encourage you guys here to try and think about, like, okay, well, what equation could we get that could relate a and b somehow? And I'd really recommend, like, pause the video for a minute here and start looking at, is there anything else you can fill in the diagram here? Are there any equations you can set up? Like, can you find any connection, any relationship between a and b here that we can work with? So I wouldn't be surprised if the first thing that many of you did is notice that these 2 things add up to 50, which means this angle here has to be 130 degrees. And if that's 130 degrees, then this has to be 50 degrees. And if that's 50 degrees, this is isosceles, which means this has to be 50 degrees. And if that's 50 degrees, then this guy up here has to be 80 degrees. The idea is, based on what we had, we know what all of the angles in this whole thing are. Right? But now that we have all of these angles, hopefully we can start to see some relationships coming together that we can work with. Right? So at this point, like, if you haven't come up with anything, think again. Think especially about this triangle. Can we come up with any relationships between a and b that we can work with here? Potentially using the law of sines. I could see you potentially using something different, but the law of sines is kind of what I was thinking here. So in particular, what I'm thinking is we should be able to say that the sine of 50 over a is equal to the sine of 80 over b. Right, I'm just using, these two sides that are opposite, these two things that are opposite. We can set that up using the law of sines. So this is one relationship between the two things that I can work with. So now I need another one, right? And this next relationship that I'm looking for is going to be a relationship that comes out of this triangle here, right? So again, maybe think about how you could use the law of sines in that triangle, right? And I'll sort of give you the beginning of it. We should know that the sine of 20 over a is equal to the sine of 30 over something. Right, what should be on the bottom of that? What it should be is basically this length here, which hopefully you recognize is 10 minus b. Okay? So now, great. I have two equations with two unknowns. How am I going to solve this thing? And this, again, I hope represents, I hope what you're going to see here is that you have a strong understanding of things from intermediate algebra. In intermediate algebra, we would have used something like elimination or substitution, and here it's going to be substitution to solve this thing. My thought is, if I can solve these things, if I could solve for a and plug them into one another, I could actually do something with this, right? So over here, I'll have b sine 50 equals a sine 80. It means I could even solve for a. I could get that a is equal to b sine 50 over the sine of 80. And in this one over here, if I sort of move things around again, I could end up with 10 minus b sine 20 equals a sine 30. And so that means that, heck, at this point we could even plug this thing in here, right? I could have 10 minus b sine 20 equals b sine 50 over sine 80 times the sine of 30 degrees. Right? At this point, I really, really want you guys to pause the video and work through the algebra of this. So much of calculus and so much of the advanced problems that we see is just manipulation of symbols. It's moving things around. It's working with these numbers. And so I really want you guys to have a chance to do this here. So pause the video, use your calculator, evaluate these things, and see what you can come up with. If you need to, you can sort of unpause the video step by step and see what I'm doing. But I really want you to do as much of this as you can on your own. Okay, so I'm going to distribute this sine 20 through this thing. I'm going to end up with 10 sine 20 minus b sine 20. And the right side of this is really just a giant calculator mess. I should be able to multiply sine 50 and sine 30 together and then divide by sine 80. So when I did all of that, I ended up here with 0.389b. Okay. And then on the other side, I can sort of, I can work through this a little bit more as well. So let's see, if I do 10 sine 20, I end up with 3.420. And then the sine of 20 here, let's see, 0.342b equals 0.389b. And a point that I sort of want to make here is the idea that you can use your calculator to do a lot of this neat stuff. One of the tricks is, if you're using an updated TI-84 or TI-Nspire calculator, you can actually use the up arrow to scroll back and grab these exact values and add them with one another, so that you don't even have round-off error. So when I do that, when I move this thing over, I'll still have the 3.420. On the other side, what I'm going to get from adding these two things together will be, so I ended up getting that it was 0.731b, and then our last step is to divide this. And again, please try not to just type these into your calculator. Use your calculator and either store values or, scroll up to grab the, I'm clicking the up arrow several times to grab that old 3.420 number, and then divide it by the answer that I just had. When I do that, I end up finding that b is 4.0 679, and so that is B, right? And I can store that on my calculator, or I can, write down more of the digits, really store the thing. So now I want to go back, and I need to find the other one. So I need to go back up and use this relationship that's up here. So we had B sine 50 over sine 80. So A is B sine 50 over sine 80. If I just plug that into the calculator, I end up with A being 3.640. And we found the values of A and B. And this problem was difficult. This problem was difficult on two levels. One, there was a lot of algebraic manipulation. Two, we had to come up with a strategy that was going to allow us to walk through this problem. Our first two videos in this sequence were pretty straightforward, just a straightforward law of sines and a straightforward law of cosines. Here we're getting into harder problems with these things. I have one more problem for us, and this one's really exciting because it's a non-calculated problem. So let's take a look at that. Alright, so in this problem, I want you to find the value of A without using a calculator. And there's a part of me that wants to say, like, okay, go. Figure it out. And I'd recommend pause the video, think for a few minutes, see if you can come up with anything here, and if you don't come up with anything, unpause, I'll give you a hint. The hint that I'm going to give you is that, surprisingly enough, I want you to use the law of cosines. I want you to use the law of cosines in this triangle up here. Right? And that's going to bother some of you because you're sort of like, how am I going to use the law of cosines in that triangle? And one more hint. This is going to be my last hint, I think. My hint is, just write it down. Set it up. Set up the law of cosines for that, and then look through the rest of the problem, look through the other information you haven't used, look and see if you can see the secret, because I was really excited when I wrote this problem. This is a really beautiful problem, in my opinion. I wrote it, so maybe that's kind of vain of me, but oh well, we'll deal with it. So the thing that I just asked you to do, and the thing I hope you've already done, is I asked you to set up the law of cosines for this. So when you set up the law of cosines for that, you end up with something like A squared equals 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of theta. And at this point, your problem-solving brain should sort of be saying, like, okay, and if your brain isn't doing this, then this is me telling you this is how the game works. We want to find A, which means there must be some way for me to find theta, or potentially the cosine of theta. So at this point, the problem has changed for you. The problem is no longer find A. The problem is now find out what the cosine of theta is. So if you haven't already gotten this far, pause the video, think through it, think how you can come up with that. Okay. Well, next big hint. These are vertical angles, which means this is also theta. And if that's theta, I would argue you should be able to tell me what the cosine of theta is. Based on this bottom triangle, the cosine of theta, this is a right triangle, ha ha ha, the cosine of theta is adjacent over hypotenuse. It should be 5 over 15, which is 1/3. And so, like, oh my gosh, we literally just stated then that the cosine of theta is 1/3. But that theta is the same as this theta. That means we can plug these things in, right? This means that A squared is equal to 16 plus 36 minus 48 times 1/3. A squared is, what is this? 52 minus 48 times 1/3 is going to be 16. So A squared is 36, which means A is 6. Oh my god, this is ridiculous. I'm sorry. I don't know. The fact that even worked out to be a nice number, unless I messed up on my number somewhere. Just the fact that we can work through problems like this without a calculator is awesome and is good stuff. So good luck when you're trying these problems on your own, and don't give up. The big secret here is perseverance and just looking for things. So I'll see you in the next one.